Okay, Mia, so 38 ends up being a lot like number 40 that I just discussed with you. So you've got vector A, which is 4i hat plus 7j hat. Vector B is 5i hat minus 2j hat. So what you're going to do is you're going to need to resolve that into x and y, you know, so A, then it's 4 comma 7. And the resultant of a vector, remember, is equal to, so any resultant is the square root of the x component squared plus the y component squared. So that's what I did right here for vector A. I took the square root of 4 squared plus 7 squared, which gives me 8.06. So that's your first answer. That's the resultant magnitude of vector A. Then you do the same thing for B. So you take the square root of 5 squared plus negative 2 squared. That gives you a resultant magnitude of 5.39 for vector B. Now, what makes this different here is the next thing is they want you, instead of adding these two, to subtract them. So if C is your resultant of that, then you have to find the x component of C and the y component. So to find the x component of C, you take AX minus BX. That's the part that people usually forget. Don't add it, subtract it, since it's a subtraction problem. So 4 minus 5 gives you negative 1. Find the y component of the resultant. So you take AY minus BY. 7 minus a negative 2 gives you a positive 9. So that means that your resultant vector here is negative 1 comma 9. They want to know the magnitude and direction, though, of that resultant. So you find the resultant of C is equal to this, the x component of C squared plus the y component of C squared square root. So that gives you a resultant of 9.06 when you subtract A and B. And you find the theta by taking the inverse of CY over CX, which gives you an angle of negative 83.7. Now remember, if you were to plot those points, since you got a negative 1 for the x and a positive 9 for the y, your vector is going to be over here in quadrant 2. So that's why we had to do this again. We need to take negative 83.7 degrees and add it on to 180, which is going to give you a theta of 96.3, which is the much better way to express it, because that's with respect to the unit circle or the positive x-axis. And then for the last part, Mia, they want you to basically just plot all of this. So what I did here is my red vector is C, the resultant of A minus B. Probably it's better for you to label it that way for your professor. So I drew that in, and they want you to show how that works out by graphical analysis. So I drew in what vector A would be here on the graph. It's going to look like that, since its components were positive 4, positive 7. And then when you add vectors, you have to do the head to tail method. So where the head of vector A is where you're going to start adding on vector B. Now normally vector B would have been this direction, but since we're subtracting it, you have to draw it in the opposite way, which is why it is showing up that way, because normally it would be a positive 5 in the x direction and a negative 2 in the y. So we're going to do negative 5 in the x direction and a positive 2 in the y direction. And so when you add those two together, this is your final position. So your resultant is where you started to where you ended, which gives you that red vector right there. And that does, in fact, look like a vector that has roughly an angle of 96.3 degrees from the positive x-axis and a magnitude of around 9.06 overall with respect to the other vectors.